Hi, this is Ken Urban with CSC 125 again. We're doing another implementation of the stack. This time we're going to use the linked list class that we built in a previous video. Recall that the linked list class has in it just a few functions: insert it back, insert it front, remove front, and is empty, which they match pretty closely to what we need for the stack class. They don't match exactly, but they're pretty close. So let's start now. We have our new class. Oh, by the way, the main program I'm using is the same one that we've been using to test the stack from the STL implementation, just the built-in STL implementation, and I copied in all those source and headers for the linked list and the node class. So we're going to add a new class again. This is going to be called stack. I'm not going to do the destructors or anything like that, although we probably should. Add to the current project, yes. Okay, so now our stack, right, has as the underlying structure a linked list called, I don't know, my list. Could have named any. And in order to get it to use it, I need to include, right, the files. So I need to include the header file for linked list. Again, it's not a namespace, so we don't have any of that. We should include it in here. And then out in main, we would include stack.h, where we'd include it from the current directory. And then we would create a stack. Excuse me. Now, just to verify, right, our node is of type string, which means our linked list is of type string, which of course means our stack is of type string. Just to make sure we have all the pieces in place and all the files here together. There's a lot of them in here. Let's just see if we compile it. Okay, so the first error says my stack.empty, right? Stack has no member named empty because I haven't written it yet. So stack empty basically just checks to see my list is empty. So it's a boolean called empty, and I need to put a return here, right? Because I got to take the value from this and send it back. My list dot, and I believe I did call it empty, right? Let's find out. It is empty. I called it here, so let's just call it empty over here. Notice I'm not changing anything in the linked list class. Right, just putting it back there, so that connects up. Let's compile it again, see where it fails next. All right. Empty, return my list empty. Oh, yeah. Wasn't paying attention to what I was doing. Try it again. Okay, now push, right? So the push, we're going to again connect up the stack push. So push is a void, which gets a string s, and then we don't return anything, but we do my list dot, and then in the list class we called it inserted front, right? Because as it turns out, the back of the stack is going to be the bottom of the queue, the front of the stack is going to be the top. So we inserted the front. Oops, front. Pop which doesn't return anything. I'm going to call mylist.remove from front. Now, mylist remove from front returns a string, but it's not being sent back here through this pop, so it's just kind of being ignored at this point. And then the last one we need to write returns a string called top. Doesn't have a counterpart in the linked list class, so I guess we do have to make a modification to it. So I'm going to go into the linked list. All right, there's a my tail and my head, so I could put like my head arrow data, but I don't want to access. He's got the little red there. I don't want to access private data. So let's go into the linked list class and let's add a string called view front, and then we're going to return my head arrow get data. What it's called. Right, so now I have something called view front, right, to be consistent. Front, front, front. And they'll call view front. And we can use that here. And we definitely want the value from here to be passed back to here to whatever it's called. And let's see what we got. Okay, so that worked. So that was yet another implementation of the stack using sort of different pieces that we have around. Thank you.